This is the lesson for Handout E. And so the first problem up here in the upper left-hand corner actually wants us to use the quadratic formula to go ahead and solve this quadratic. So remembering that the quadratic formula works this way. It's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And this gives us our x-intercepts. So we've got to know what a is. A is the number out in front of x squared. B is the number out in front of x, and C is the constant, the one without an x next to it. And so we go ahead and substitute these numbers in there. It's the opposite of 5 plus or minus the square root of 5 being squared minus 4 times a, which is 3, and c is 2. This is all over 2 times by 3. So we go ahead and do some work there. It's negative 5 plus or minus the square root. We do this work, we get 25. And notice there's only one negative sign here. So it's 4 times 3 times 2 is 24. But since there's only an odd number of negatives, only one negative, it makes a negative. So we're going to end up subtracting that number from 25. And this is all over 6. And so now it's negative 5 plus or minus the square root of 1 over 6. And now we can go ahead and do the work. So if we couldn't take the square root, we'd just leave it that way. But right now we'll go ahead and take the square root since we can. It makes negative 5 plus 1 over 6. And we also have negative 5 minus 1 over 6. So we do some work there. That's negative 4 over 6 makes negative 2/3. That's one of the solutions. The other one's going to end up being negative 1. So those are our two x-intercepts. Here we're graphing this. Now when we graph, we're going to use this find out what the vertex is. The axis symmetry is the first part of the vertex, and it's negative b over 2a. So it becomes from this quadratic formula, negative b over 2a, this part right here. When the plus or minus b squared minus 4ac is 0, that means that this is the center, kind of the starting point of this parabola where it changes directions. And so we go ahead and substitute those numbers in there, but we don't have a b term, so it's 0 over 2 times 2. That just makes 0. So when you substitute 0 back in to find the y component, you end up just with negative 5. So that's where we're going to end up starting, is 5 spaces down on this from the origin, and then follow what the parent graph says. Now the parent graph is a y equals 2x squared. So if you square 1, you're going to end up multiplying by 2, and that's going to give us 2. So over in the x direction 1 space brings us in the y direction 2 spaces. Notice x is 1, y becomes 2. If x were negative 1, we'd still get 1 times by 2 would still give us 2. If we square 2 or negative 2, we get 4. Times by 2 gives us 8. So over 2 spaces brings us up 8 spaces. And then we can go ahead and graph that parabola. Well, look at the next one. This time we do have a b term. Notice the a term's negative 1, and the b term is 6. The c term is negative 5. So we go ahead and substitute those numbers in there. We have negative 6, because it's negative b, over 2 times negative 1. So that just makes a positive 3. The negative signs will cancel. So now we substitute that 3 back in for the x's, and here's what we get. We get y equals, now notice it's the opposite of 3 being squared, so it becomes a negative 9 plus, and then this makes 18, minus 5. So the first two terms should be opposite in sign, which they are, and one double the other. So 9 minus 5 makes 4. So that's where we're going to start, is 3, 4. This is where the two lines, this is where the parabola's vertex is. So 3 spaces to the right, 4 spaces down, we've got our dot. Now the parent graph is a y equals opposite. Oops, and actually I went 4 spaces down, so let's fix that real quick. Should be 4 spaces up. So let's go ahead and go over 3, 4 spaces up. That's 3, 4 right there. So this time the parent graph is a y equals the opposite of x squared. Now I caught my mistake because I saw that was the opposite. And opposite means you're going to end up opening down. And it wouldn't have been able to fit very well in my graph. It should fit there. So let's try this. 1 squared or negative 1 squared gives us 1. But then we've got to multiply by the opposite, or take the opposite, multiply by a negative 1. So that's why you always end up going down when it's a negative x squared. 2 spaces to the right or the left brings us down 4 because we times it by a negative. So over 2, down 4, and we've got a couple points. And so from there, we can go ahead and draw that graph. So we've got something here real quick. The values of y or x when y is 0, these are called solutions, or x-intercepts, or roots, or zeros. Notice that's 1, this is 5. This is where the graph crosses the x-axis. Those are solutions that you'll have to find for other problems on tonight's homework as well. Here we're supposed to use the discriminant to find out how many real solutions there are, or x-intercepts. The discriminant is a portion of this quadratic formula right here, the b squared minus 4ac. See, if this square root of b squared minus 4ac was positive, that would give us 2 solutions. 2 because that means that we have to add or subtract that value. If it's a b squared minus 4ac is equal to 0, that means there is just 1 solution. And if this b squared minus 4ac is equal to a negative, that means we have no solutions. No solutions. So let's go ahead and check out how many solutions we have in ours. So we go ahead and substitute in there. We've got the b squared is 2 squared minus 4 times 3 times 8. And that gives us 4 minus 96. Well, that's negative 92. And so that means there are no solutions. No x-intercepts would be the answer. Well, the next one's a projectile problem, and we want to know when it'll impact the ground. So what we're going to do is we're going to put 0 in place of h. That's what impact the ground means. Ground means 0 feet. And so what I'm going to end up doing is I'm going to try to factor. But before I factor, I'm going to divide this by a -1, or multiply by a -1. All the signs will end up switching. 5t squared minus 18t minus 8 all equals 0. So now I'll go ahead and try to factor. And when I look at it, I'm going to try a 4 and a 2. Put the 5t here and the t here, and this will make a 2t. Take away 20 makes a negative 18. And so I go ahead and solve. I end up with t is 4 and negative 2/5. Negative 2/5. Got to divide by that 5, not by the 2. So negative 2/5. And so which answer do I take? Well, don't take the negative answer. Go with the positive answer one, because we're dealing with time. And anytime you deal with time or distance, always go with the positive answer. So 4 seconds is the time it'll take it to impact the ground. Next question. Here's a job equals rate times time problem. And when we're dealing with these, we need the reciprocal of the time is going to be the rate. See, Ted does the job in 8 hours. That means he can do 1/8 the job in 8 hours. And so 1/8 the job is Ted's amount. Well, the next person, Ed, can do that job in 12 hours. So his rate is going to be 1/12. He can get 12 parts of the job done each hour. Well, if we add those two rates together, that'll give us how fast they're working together, the rate at which they're working. And notice the job is always going to end up equaling 1. So let's go ahead and change that right now. 1, it represents 100%. And so we can go ahead and come up with a common denominator right now. Multiply this 8 by 3, the 12 by 2. We'd end up with 3/24. 3/24. Let's fix that real quick. And then the other one's going to end up being 2/24. I was getting ahead of myself because I know those add to make 5/24. And that's the rate at which they're doing the job. Now the time, well, you just multiply by the reciprocal. And you see, then the 24/5 will cancel out the 5/24. But you do the same thing on the other side, and then you have your answer. So the time at which it takes them to do the job together is 24/5. You just divide 5 into that number, you get 4 hours and 4/5. So 4 and 4/5 hours it's going to take them to do the job when they're working together. Well, the next problem here asks us to determine whether each relation is a function. Well, what you're looking for are the domains repeating, because if the domains have 2 ranges, it's not a function. In order for it to be a function, domains must have one range. If they have multiple ranges, then it's not a function. So look at the ranges. The domains are 3, 4, 2, and 4. They're all different. So each domain domain has one range. So that tells us that it is a function. And so I'll just write function here. Well, in this one, though, the domains are the ones it starts at, and then that points to the range values, because domains are values, are inputs, ranges are outputs. Here, this domain has two ranges. Notice that the domain 1 has two ranges. So that means this is not a function. Well, here are some graphs. To check graphs, use the vertical line test. Notice if I pass vertical lines through, it only touches one spot on the graph. So this passes the vertical line test. And so it is a function. The next one, however, though, when you pass a vertical line through, notice it has two ranges. So this domain, this vertical line, has two ranges. So this fails vertical line test. So it is not a function. And looking at our last one, they just want us to find domains and ranges of this expression. So all I would do is look at the points and just name off the x values. So here are my x values, which are the domains. And the domain for this point right here is its two spaces to the right. So this is a 2. This is a 1, and those are negative because they're to the left of the origin. So we got -2, -1. This one is 1. And this one is 2, and this one is, looks like 4 spaces over. So we have -2, -3, 1, 2, and 4. Those are the domains. Well, the y's are the range values. So the ranges are the y components. So let's start down at the bottom here. Looks like -2. Do these in a different color here. -2. So we got -2. And then here we have +1, 2, 3, and it looks like you go up 5. So 1, 2, 3, and 5. So those are the different range values. Well, those are problems that you'll see on Handout 5. Good luck. Or Handout E. Sorry, good luck.